So let's start by talking about why AI and object storage are basically inseparable at this point. And the primary reason is that the scale is fundamentally different this time around, right? The petabyte is the new terabyte. You know, what used to be hundreds of terabytes, and that was large for a database, that no longer exists anymore. That's why databases are now based on object storage, because petabytes is really the new terabyte. And pretty soon we're going to see that move into the exabyte class scale problem. We're not there today. We have a handful of customers that we'll talk about today that are in that exabyte level, but we're seeing more and more customers start to think about that on a regular basis. The second thing is that, you know, when you start to get at this scale, it really stresses older technologies. There's a great piece out there from Tom Nats, who was one of the original founders of NFS, talking about why NFS must die. He speaks about the challenges that you have at this type of scale, and there's nobody who's more qualified to speak about that. And he's looked at this problem very, very carefully. There's a great YouTube presentation about it. There's a podcast that he's done as well. But you know, this concept of true scale at hundreds of petabytes and what it does to a lot of these technologies, the wheels just come off the car. And so we're going to talk about why that doesn't happen with object storage and why it's uniquely suited for these problems. The scale is also very distributed, which again creates certain challenges for certain technologies. But more importantly, that data is getting created at a massive volume. We're going to give you some examples today of what we're seeing from some of our customers. But it gets created every single day and in all types of different ways. So it's video, it's audio, and if you think about all of the new advancements that we're seeing in large language models and audio prompts, that back and forth of you talking to the large language model, the large language model talking back to you, is going to create a tremendous amount of audio. But video is the primary driver. Audio, you have log files, once again, which is sort of the unappreciated giant in this space. We have one customer that's producing 250 TB a day of log files just on our platform alone, and they're in the security space. But it gives you a sense of what that overall size looks like. And then you have this distributed hybrid environment. So, you know, you talk to a Fortune 500 enterprise, they probably got, it looks like 3.4 clouds. They've got almost 4 private clouds. And so you have to be able to operate in a hybrid world as well. And when you operate in that hybrid world at this scale, you only have one choice, and that's the cloud operating model. So it's things like containerization, it's orchestration. It's things like APIs and microservices, and RESTful APIs at that, like S3. So these are the things that you have to have in order to deliver at that scale. And more importantly, it's proven at that scale, right? It's proven by the hyperscalers to work at an exabyte. It's proven by MinIO to work at an exabyte. And that cloud operating model basically has completely blurred the line between the public cloud and the private cloud. You have all of these organizations that are taking their learnings from the public cloud, repatriating it to the private cloud, and the only thing they're doing is updating their bucket names, right? That is a significant change. The technology that you now drive the private cloud with is the exact same technologies that you went to the public cloud to take advantage of. This has caused enterprises to think differently, right? So we sit in a sort of a unique position because of our footprint, because of our scale, and because of you know, our focus on very large enterprises, that we have a lot of conversations with them about kind of what their future looks like, what their ambitions look like. And so they're thinking AI first, right? I think everybody who's a delegate in this room knows from talking to their clients that this is something that every conversation is injected with this. But what about AI? How does AI fit into this? How will this scale from an AI perspective? It's early, but it's pervasive. And even in this world where we know we're going to reach a point where there's going to be some disillusionment, the stakes are so high that the CIOs and the CTOs and the CDOs that we talk to, they're just going to play through, right? Because they don't have a choice, because the option of pulling back and being conservative has such career implications for them that they're going to drive through this thing. And so I think that we're going to see any disillusionment is going to be more public than it is going to be spend driven. But speaking of spend, they're thinking about technology, solutions, and economics, right? They're not going to repeat the same challenges that they created for themselves when they went to the public cloud en masse and realized that the economics were unviable, right? That's why you're seeing such a wave of repatriation that's even unrelated to AI. But as they think about designing their AI frameworks and they think about designing these architectures, they know that they have to design for economic viability at the same time. And so that means inherently that they're going to start to look to pull that stuff back onto a private cloud where they have a much better handle on the costs, generally about 60% savings. And they can do that with software-defined storage. They can do it with commodity hardware. They can understand and separate out from a procurement perspective what they're paying for and what they're getting value from. And that's a very important thing that we're seeing emerge even today. There's also another element in that, and that element has to do with control, right? You'll even see, Databricks CEO was on the other day talking about how you should never give your data to any vendor, even them. And this is a guy who resells S3 for a living. And here they are talking about control, and control is a huge portion of it, right? If you listen to what Elon Musk says in this space, he's like, I would never give my data to a public cloud to allow them to train on my data, because basically you're ceding competitive control. Data is this huge element of leverage for you from a competitive standpoint. You can't be giving that to anybody else. And so having control of that, having it within your four walls or an Equinix Colo is where it needs to be for you to get maximum value out of that and for you to protect the organization on an overall basis. So control is a big driver of the thought process today where it wasn't maybe 5 years ago. And then finally, it's about getting big and then getting bigger from that, right? There's a new unit of scale that we put out from a reference architecture that Rakshit is going to talk about here shortly, and it's the Datapod architecture. But that's talking about building in scalable units of 100 petabytes. But that's not unusual these days, right? I mean, I remember early on when I started with MinIO, if we had somebody come in and it was a petabyte, it was all hands on deck. We thought that was, that was a good amount of data. That is, that's table stakes at this point, right? We are so much further than that. And we've started to see this really starting in kind of the last 2 quarters of last year, where we started to see a lot of these inbounds and a lot of these discussions that were 4, 8, 10 times what we had talked about them just a year earlier. And so we are seeing this massive acceleration. And more importantly, there's a huge set of stakes associated with this. There are no do-overs. If you pick the wrong technology, you get to 100 petabytes and you realize it won't go to 101. You can't just add more servers. It's over. You got to stop, restart, something completely new. And we know this because we had a customer who got to that point and they just couldn't get to that next, literally 1 petabyte because everything froze up. We'll talk about some of the challenges from a technology standpoint, but this is a really important component. Now, we had a little fun with this. Hopefully you'll have a little fun with this as well. We went and asked all the top LLMs, what were you trained on? And again, we're here to tell you in this section that this is all about why object storage and AI go together. Almost all the top LLMs will tell you in their own words that they were trained on an object store, okay? There is one exception. We totally acknowledge that Llama was trained on a filer. We think that's a function of the fact that they don't have a good object store, which is why they're building themselves a new one. But for the most part, every single one of these is publicly, and then will tell you themselves, built on an object store. And the reason for that is performance at scale, right? It's the ability to perform over very, very large data sets with unstructured data across a variety of different data types, the diversity of that data, and to do so very effectively.
Hi,
Yes.
Rohan here. So I have a question. When we say that it is, so we all know that object store also has latency problems, right? It's not as fast as local disk
Yeah.
or SAN and NAS solutions. So training, if we want to train a lot of on lot of data, uh, will it not affect in terms of performance? And I mean, like throughput is good on object stores,
Yep.
but if we see individual IOPS, that's not great, right? So what's your
So
take on that?
we're going to talk about that because a modern, properly architected object store will actually give you throughput and IOPS. And so we're going to share some stats with you today specifically on that. And it's funny that you mentioned that. It's in the slide after this.
Oh, okay.
But we're going to talk about when you want to be performant at scale, it's not just about throughput, which again, object storage is absolutely optimized for,
Right.
but it is about this IOPS piece.
Okay.
And so, you know, there are some obvious trade-offs that you're going to have there. But for the vast majority of training that goes on, it is a throughput game, right?
Okay.
And so that's what you see, and that's why you see every one of these major models is trained on an object store. If that was seriously a constraint, they would have, come up with some different approach.
Right.
But every one of them is trained on an object store. And AI and ML, if you look at the pipelines that get created, they've always leveraged object stores. So we just looked at the Databricks model, which is open sourced, and you start with kind of the pipeline and feeding that pipeline into an object store. And obviously that is something that object stores are ideally suited for because all of the cloud operating model and ecosystem from a pipelining perspective looks at an object store with, as a first-class citizen. Then you can pre-process that, which takes those billions of documents into trillions of records, right? Then you start to train your model. And guess where you save your checkpoints? Back on an object store. And we're going to show you that actually in our demo today, that we're just doing that automatically for developers at this point. Then you save those models. Guess where you save those models? You save them back on an object store. And then you serve those models. And guess where you serve them from? You serve them from an object store. So at every stage of a modern AI and ML workload processing standpoint, you're using an object store because that gives you, again, the performance at the scale that you want. And to answer your question specifically, it is a performance at scale game these days. It is one thing to be performant at 100 terabytes. It's another thing to be performant at 100 petabytes. It's an entirely different game altogether. Things that work here simply do not work here. Right? If you have a third-party metadata database, it'll work here. It will not work here. Right? There's a variety of reasons for that we'll get into today. But those types of architectural decisions that may work at, again, what you thought was big in the old days doesn't work in the new days. And so I think that's the most important thing that we want people to take away is that only object storage can play at this scale. Right? And that's a scale that we're going to. And it seems very big to everybody today, but it's here already. And I think that's the important thing. And performance is defined by, IOPS and throughput, right? And so we're going to discuss how you get to both of those things, right? And it's got to be able to perform at small objects and at large objects. And we're going to show you that again as we go through the days as well. So, listen, as you draw out that scale, things that worked at small scale don't work at large scale. And we're going to talk specifically about where SAN and NAS fits in that equation. We're not telling you that SAN and NAS are going away. They're not going away. But we're telling you that in the game of AI, object storage is the dominant storage platform. And we think that we're very well positioned in that. And that's what we're going to be kind of laying out for you, that case today. And again, economics and performance are related. Nobody has an unlimited budget. Everybody has read some of the stats around some of these large-scale data infrastructure challenges where people are buying tens of thousands of GPUs, spending $1 billion plus on those GPUs, right? But that's, again, that's not an unlimited amount of money. And for the vast majority of organizations that aren't building foundational models or aren't betting the entire future of the company yet on those models, there has to be some economic use case there, right? In the case of one of our customers in the self-driving space, they can make that justification because this concept of full self-driving is so important to the future of that organization that it's part and parcel with what they're doing today, right? Not every organization is going to have that. You have to have economic viability. And so you have to look out and architect things that make sense in that world. So there's a number of features that favor object storage for AI over other approaches and other technologies. So one is that the RESTful API model really allowed developers to break free from the legacy approaches, the chattiness that comes with a POSIX interface, and allowed them to do things that were much simpler, right? Get, put, list, delete, all of these different things. You also have much greater fine-grained controls over what goes on from a security perspective. This is very, very important in the AI world. So object-level encryption is something that you can do with object storage that you can't do with other technologies, where you have to encrypt at the volume or the file system level. You can do this at an object level, which allows you much more fine-grained control. You have this basically change from mutable to immutable. Now, that obviously has a lot of implications in a world where ransomware has become basically, a high-stakes game. It's sports league. You got teams named after them, and all these things. But immutability is a fundamental principle of an object store, and it's a very, very powerful one there. You also have the ability to have continuous data protection, and so this comes as a huge advantage, right? So the old kind of NetApp snapshotting model really doesn't play well. With an object store that's properly architected and versioned and in place, you can basically rewind to any point in time that you want, right? Any point in time that you said, all right, I want to go back to that. And it's really important as you think about your models and developing models, because you can go back to a point in time, you're like, I want to go rerun the model here. And you can find that point in time. That's a unique object storage feature that distinguishes it, particularly in the age of AI. You've got active-active, strictly consistent replication. So once again, driving high availability, right? Driving data integrity and doing so over a very large distributed global system is something that's really critical. And so we have multiple clients who are doing this today, because if you think about a world in which your capacity utilization for these incredibly expensive GPUs has to be at 100%, you simply can't have one side go down, right? So you need to be able to set up an architecture that allows you to basically continue to take advantage of that infrastructure. And then finally, simplicity. One of the things that makes object storage so unique is that, again, the S3 model is far simpler than the older model and the older approaches. And that simplicity scales. And for those who've been around us know that we are literally obsessive about simplicity. The ability to get MinIO up and running in less than 60 seconds is a well-known fact. We've written blogs, other people have written blogs, people have done videos about them. We're going to tell you a story about how we went from 0 to 290 nodes over a long weekend back in January. And that, is unheard of when you think about it. But simplicity scales operationally, it scales technically, and it scales economically. All the things that we talked about that are important in the AI world. So what I want to do is just kind of close out this section. We live in a world where AI is the dominant conversation. And that conversation revolves primarily around setting up an architecture that involves object storage for the reasons that we talked about earlier. The scale is different this time, and the scale that we're talking about is breaking older legacy technologies. Your ability to perform at scale is also one that's significant, right? And we're going to continue to see the data growth outpace the compute growth. Now, we still live in a world where we have GPU scarcity, but that scarcity is easing, as we have seen in recent quarters. And then I think the last part that was really important is that the feature set matters, right, from an object storage perspective. The capabilities that it brings to the table are uniquely suited for the challenges that enterprises face when they start to do large-scale data infrastructure. Again, exabyte scale, we're going to talk about very specifically some use cases where we've been able to do this.
Jonathan?
Yeah.
Hey, have you, I can't remember if you guys are involved with MLPerf storage. Are you involved with them? And especially since we're talking performance and how it matters at scale in terms of that benchmark that's going.
MLPerf. Yes.
Yes, they all nod.
So Yes. So just to set some context around that, MLPerf suits, I mean, the support for object wasn't there. So we did, contribute back to the PyTorch Foundation, and we are in the process of leveraging whatever we contributed back to basically tweak the MLPerf test suits and run it natively on object store. So that's something that's work in progress.
Are they embracing that then, the MLPerf committee?
I mean, we would be one of the first ones to kind of do that. So we will definitely reach back to the community and share our results and our thoughts on that.
Okay, thanks.